Hi everyone. I hope you people have written the GATE examination well, and I hope you have already checked your solutions from the ACE Engineering Academy. Now I'm going to provide you the video solutions for the questions appeared in GATE 2021 for both morning session and afternoon session. And as I told you, either in the case of the deep learn platform or in the online sessions, the minimum marks that you attain from the geotechnical engineering is 13, maximum is 15. So this time also, IIT Bombay, so they didn't disappoint us. They have given 14 marks in both the papers. So now let's see how the question has gone and how you have attempted the questions and where you went wrong through the video solutions. So let's see that. So let's come to the geotechnical engineering morning session. So if you see, the first question attained here over here. This is a 1 mark question. So based on the drained triaxial shear test on sands and clays, I have clearly mentioned the results from the direct shear test. So if you go through the notes, I have given all these type of graphs. In the previous one of the GATE question in GATE 1995, that's long back, they have asked a question based upon the results of the drained triaxial shear test and direct shear test. So they have given the question, the similar type of question, but that is a stress versus a strain. But now you see, based on drained triaxial shear test on sands and clays, the representative variations of volumetric strain. So this is a change in volume, volumetric strain with the shear strain is shown in the figure. So this is the figure, and what is curve P and what is a curve Q. So this question, if you observe, I told you in the case of the dense sands and over consolidated clays, what happens? And in the case of loose sands and the normal consolidated clays, what happens? So during shearing, listen, during shearing, in the case of the loose sands, particles will get orient. Yes, particles will get orient. In the case of the loose sand or normally consolidated clay, during shearing, the particles will undergo compression. The particles will undergo compression, results in reduction in the volume with respect to the strain. When the particles undergo compression, the reduction in the volume with respect to the strain, shear strain. So if there is a reduction in the volume, that is going to be seen in the case of loose sands and normally consolidated clays. And what happens in the case of dense sands? In the case of dense sands, during shearing, initially volume reduces. Initially volume reduces. You see, this is negative axis up to certain extent. And then what happens is, in the case of dense sands, the interlocking between the particles will breaks. Initially volume decrease, but it goes up to certain extent, and beyond that, the interlocking between the particles will breaks. And when the interlocking between particles will break, now the dense sand is going to be behaves like a loose sand, and the volume starts to dilate, means increase in the volume. So in dense sand, initially volume decrease and interlocking between particles will break down, and from here onwards the volume is going to be increases. So if there is a reduction in volume and increase in volume, that is going to be said as a dense sand and over consolidated clays. So this is going to be said as dense sand or over consolidated clays. And here this is going to be loose sand or normally consolidated clays. So now curve P represents dense sand or OCC and curve Q represents loose sand or NCC. Let's see the options. If you look over the option, choose the correct option regarding the curve P and Q. Curve P represents the loose sand. No, curve P means dense sand. So option A, eliminate. Curve P represents the loose sand. Again, option B, eliminate. Now come to the C. Curve P represents dense sand and over consolidated clay, while curve Q represents loose sand and normally consolidated clay. So I told you the curve P is dense sand or OCC. If you observe, curve P represents dense sand and over consolidated clay. So the correct answer is option C. Option So I have already explained this in deep learn platform and in online sessions. So this question is a 1 mark question. Now let's see the next question. So if you see this question is a 2 marks question obtained from the physical properties of the soil masses. So you observe where in what chapters the questions has been asked. Earlier question number 1 is from the shear strength. Now this is from the physical properties. So I have given you the partially saturated soil sample which is having a natural moisture content of how much? 25%. So given moisture content is 25% and bulk unit weight, so gamma is 18.5 kilonewton per meter cube. Specific gravity G value as 2.65, unit weight of water as 9.81 kilonewton per meter cube. Now my question is, what is the unit weight of soil on its full saturation? See, given the soil is partially saturated, okay, whatever this moisture content is partially saturated. If you are going to make it as fully saturated, what is the unit weight? They are asking. So I want gamma sat. So how to obtain this gamma sat, sir? See, one thing is clearly from partially to fully saturated, no change in volume. Is there any change in volume? No. I told you from dry state to the fully saturated state, yet up to just full saturation, no change in volume. If there is no change in volume, there is no change in void ratio. And now first my content is, I will find out the void ratio. How, sir? Sir, we have gamma and we have water content. Once you know gamma and water content, can't I find out the dry unit weight? Yes. So now if you observe, so you know that gamma D is equals to gamma by 1 plus W, and this gamma D can also written as G gamma W by 1 plus E. Yes. So the given gamma is 18.5 and water content is 25%. So which means 18.5 by 1 plus water content 25% is equals to, what is G value given? 2.65. So 2.65 into 9.81 by 1 plus E. So if you solve this, you are going to end up the E value as, so that E value is equals to 0.756. And once I know the E value, I can find out the gamma sat. That's it, right? See, first from the given data I have find out the E value, and now gamma sat is equals to G plus E by 1 plus E into gamma W. That's it. You substitute 2.65 plus 0.756 by 1 plus 0.756 into 9.81. After solving, you will be ending the answer as, so you are going to end up the answer, the gamma sat value is equals to 19.03 kilonewton per meter cube. If you look, so the given options are going to be 19.03 kilonewton per meter cube. Answer D. Those who have kept the answer D, they got the answer. This is one way, or else there is the other way also. The other way I am not going to solve it. So you know the solution, right? The other way, what I do is, see, you know Sehwag, right? The other way, method 2. So E into SR is equals to W into G. Anyways, you have water content, right? 0.25 into G value as 2.65. Yes. So now what you can do is, you know gamma, right? You know gamma. What is gamma generally? G plus ESR by 1 plus E into gamma W. Okay. So this is other way. Earlier what I have done is I have find out gamma d and I written the gamma d equation. From there I can find out the E value. But now what I am doing here is I am writing the gamma equation directly, and from the point of gamma. So now you substitute E into SR over here. So you know gamma. What is gamma? Gamma is 18.5 is equals to G 2.65 plus 0.25 into 2.65 divided by 1 plus C. You take this gamma W to this side, divided by 9.81. After solving this one also, you are going to end up the E value as 0.756. Either you use gamma directly, you can find out E value, or you use gamma D. See, while I was explaining in the videos of deep learn and online, I used mostly gamma D. So that's the reason why. As this is a familiar approach, I have gone through this method. So those who have done this procedure also, there is also going to be correct. Once you know E, you substitute in the gamma sat, then you can find out the gamma sat as 19.03. This is a 2 marks question, my dear. Now, coming to this question. So this is very good question, and this question is coming from foundation engineering topic earth pressure theories. So here there is a new type of model, a small little bit extra thing they have mentioned is, now observe, a retaining wall is of a height 10 meters. So they have given a retaining wall. So this is a retaining wall given as a 10 meters and with a clay backfill as shown in the figure. The weight of the retaining wall is 5000 kilonewtons per meter, acting at 3.3 meters from the toe of the retaining wall. So the weight is 5000 kilonewtons. You see, the weight of the retaining wall is, what is the weight of the retaining wall? 5000 kilonewtons, which is acting 3.3 meters away from the toe. Okay. Now the interface friction angle between base of the retaining wall and the base soil is 20 degrees, which means they have given the friction angle, base friction angle. So now the base friction angle, they mentioned it as so here delta is equals to 20 degrees, my dear. Okay. And now the depth of the clay in front of the retaining wall is 2 meters. So whatever the depth of the clay is 2 meters. The properties of the clay backfill are placed and assume the tension crack is filled with the water. Using Rankin's theory, take unit weight using Rankin's earth pressure theory. So now I am going to use the Rankin's earth pressure theory. I have given all the properties. This is the retaining wall, 10 meters. This is the properties of the clay, 17.250 and C value 30. The factor of safety I am asking you, and that too against a sliding failure. What is the factor of safety against a sliding after ignoring the passive earth pressure? You see, this wall, this soil will exert active and this soil will exert a passive. As they are saying, ignore the passive earth pressure. Passive earth pressure. The soil, the clay soil next to the toe will be neglected. We don't consider anything next to the toe. We don't consider anything next to the toe. Okay. So now let's see how to find out the factor of safety with respect to sliding. Factor of safety with respect to sliding is equals to mu into sigma v by sigma h, means where mu is a coefficient of friction. As they have given the base friction angle delta, you know that mu is equals to tan delta. Tan delta, yes. So now it's all about finding the sigma v and sigma h. Okay. What is the total vertical over here? The total vertical is nothing but weight, right? The total vertical is nothing but weight, which is nothing but 5000 kilonewtons. That's it. There is no doubt in that. But it's all about sigma h. And now, what is the sigma h? So let's see how I'm going to find out that sigma h. And they mentioned that the factor of safety after the wall ignoring. So and there is said that the tension crack is filled with water, which means there is a tension crack and then the crack is filled with water, because as this is a clay deposit, you know that in the case of the clays, due to cohesion, tension crack will develop. Yes. So now let's take the same figure. It's again. So whatever this is going to be the retaining wall. Just I am taking in a different way so that you can be able to understand. So this is a 10 meters and this is a crack, and this crack is going to be filled with whom? Water. So this crack is filled with the water. Okay. So this is water. And whatever the clay soil mass on the toe side, just neglect it, because you are neglecting the passive earth pressure, right? So now let's see, if I draw the active pressure distribution, you know how does it looks like. So on the top it is going to be negative, at the bottom it is going to be positive. Yes or no? And in between from positive to negative. Okay. So this is going to be the active pressure distribution. Yes or no? Yes. So here this is a negative and here it is going to be the positive, and this is the depth up to which the tension crack is going to be developed, ZC. And apart from this, now the new thing coming over here is this tension crack is filled with water. Are Baba, the crack will fill with water once the tension crack is completely formed. Yes, after the formation of tension crack. After the formation of tension crack, I told you, you don't need to consider this negative zone, tension zone. Now, so after the formation of the tension crack, I told you, you neglect the tension zone. Yes or no? So we need to neglect this tension zone. We need to neglect this tension zone. And then that tension zone is going to be filled up with whom? Water. And once this water is going to be filled up, this water will exert some hydrostatic pressure, my dear. This water will exert some hydrostatic pressure. Yes or no? So now, if you observe, so whatever the water over here, this water will exert a hydrostatic pressure. So this is hydrostatic pressure. So what is this hydrostatic pressure? Gamma W into ZC at this depth. Yes. So now observe carefully. See, on the back of the retaining wall, due to clay backfill, this is the active pressure distribution. And now, as crack is going to be formed, I will simply neglect this active earth pressure. So I will simply neglect this active earth pressure. So now what we can do is a backfill, and we are going to consider only this zone. We neglect this zone. We neglect that zone. So whatever the forces now acting on the wall is, number one, this force, let me take this one as a F1, and due to the water it is going to be F2. So what is the net horizontal forces over here is nothing but F1 plus F2. But in order to find out the F1, so in order to find out the F1, first of all you need to find out this height. So if you know the ZC, my dear, then you can find out the remaining height. That F1 is nothing but area of this pressure distribution. Yes or no? So first you find out the ZC. You know that how to find out the ZC. So ZC is equals to 2C by gamma root Ka. Yes. And you see the details over here. if you see the details, phi is equals to 0, right? When phi is equals to 0, as phi is equals to 0 degrees, Ka value is equals to 1 and gamma 17.2. So 2 into C value is 30 by 17.2 into root 1. So if you solve, the ZC value is going to be 3.49 meters, my dear. Are Baba, the ZC value is going to be 3.49 meters. So if this is going to be 3.49 meters, now what about the remaining value? What about this remaining value? Come on, tell me. So 10 minus 3.49 meters. So this is going to be 6.51 meters. That's it. Now we need to find out that F1 and F2. Understood or not? So what is this F1 area? So now for that I need to find out what is the active earth pressure at the base of the wall. What is the active earth pressure at the base of the wall? So now active pressure at base of wall. So what is the active pressure at the base of wall? You know that. How you are going to find out? Ka gamma h minus 2c root Ka. Ka gamma h minus 2c root Ka, and now as you neglect the tension zone, so now this negative pressure also going to be added over there. Yes or no? So first of all, we just find out what is the pressure at the bottom. Ka gamma h minus 2c root Ka. So 1 into gamma 17.2 into h 10 minus 2 into c into root 1. So if you solve, this value is going to be 112 kilopascals, my dear. So what is the active pressure at the base of the wall? So now this is going to be 112 kilopascals. Similarly, what is the hydrostatic pressure? What is the hydrostatic pressure at the bottom of the tension cracker? So the hydrostatic pressure gamma W into ZC, right? So now hydrostatic pressure, which is going to be gamma W into ZC. So gamma W 9.81 into ZC value 3.49 meters. So if you solve, this is going to be 34.24 kilopascals. So 34.24 kilopascals. So this value is going to be 34.24. 34.24. So 34.24. So now once we know this value, now this F1 and F2 is nothing but area of the pressure distributions, right? So once we know this, now let's find out the sigma h. So what is sigma h? Sigma h is nothing but F1 plus F2. So what is F1? Half into base 112 into 6.51. Half into base 112 into 6.51 plus what is F2? F2 is nothing but area of this hydrostatic pressure, right? Half into ZC into 34.24. Half into 3.49 into 34.24. So this is a sigma h, and after solving this, the entire sigma h is going to be 424.31 kilonewton per meter length, because we are taking per meter length of the wall, right? Yes. So eventually I got sigma h. So you see what I have done. First, the theory, you need to understand one thing. Once the crack is going to be formed, then you don't need to take care of this negative zone. You neglect that. And as the crack is filled with water, you have to take the hydrostatic pressure also. So now there are two lateral forces. F1 is due to soil active pressure, F2 is due to hydrostatic pressure, and already we know the sigma V. So once we know all these values, see what is a sigma H, 424.31. So now factor of safety is equals to mu 5000 into tan delta tan 20 by 424.31. So this factor of safety is equals to 4.29. That's it. What is the factor of safety? 4.29. So we are going to round it off, and the round off to 2 decimals. So once you round it off, you are going to end up the answer as 4.29. This is one of the very good question. The thing is, what if the crack is filled with water? That's it. So that's about this question. Now let's see this question. There is also 2 marks question. The soil profile at a construction site is shown in the figure. So this is a soil profile. So if you observe, so this is nothing but the ground level. It consists of a 2 layer. One is sand, other one is clay. And for the clay and for the sand, so I have given you, means in the question, above water table what is the unit weight, below water table what is the unit weight, and for the clay also the unit weights were given. Now groundwater table is at 5 meters below the ground level at present. So present means now. At present, the ground water table, present water table is at a 5 meters. But an old well data shows that the groundwater table was as low as 10 meters below the ground level in the past. So present it is 5 meters, past it is 10 meters, which means either due to heavy rains, the ground level means the groundwater table has been raised. Now what I am asking you is, take unit weight of water as gamma W 9.81. So now let's represent so this is going to be the past water table, which is located at a depth of 10 meters. So this is a past, and here it is going to be, this is present. So what is the over consolidation ratio at the midpoint of clay layer? At the midpoint of the clay layer. So the midpoint means which is at a depth of 4 meters, right? So in the case of the clay layer, see what is over consolidation ratio? The over consolidation ratio is nothing but pre-consolidation pressure by present stress. Yes. What is the meaning of pre-consolidation pressure? Pre-consolidation pressure means the maximum pressure at which soil got consolidated. The maximum pressure at which soil got consolidated. Okay. So that is the pre-consolidation pressure. So first of all, we know that there are 2 stresses over here. At the center of the clay layer, due to present groundwater table, there must be one effective stress. Due to past water table, there might be one effective stress. So we need to find out the effective stresses. Here the stresses is nothing but effective stresses only. Na? So let's find out what is the effective stress in past and present. Okay. So what is the past stress? Which means when the water table is at 10 meters. So if the water table is at the 10 meter below, now at the center of the clay layer, if the water table is 10 meter below, in the first 10 meters, now it is going to be gamma. In the first 10 meters, it is going to be gamma. And then what is the total here? 15. Na? So what about the remaining 5 meters gamma sat? And as I am asking about the effective stress, it is going to be gamma dash. So for the past, water table is going to be locating over here. So find out. Yet center of clay layer, effective stress. So effective stress is equals to gamma of sand into 10 meters, because water table is at a depth of 10 meters below, plus gamma dash of sand into 5 meters plus gamma dash of clay into 4 meters. That's it. Because in first 10 meters gamma, next 5 meters gamma dash, and next 4 meters clay. Okay. So you know what is gamma of sand 17.5, gamma set 18.5, and in the case of clay gamma is 17. So now effective stress is 17.5 into 10 plus gamma dash of sand 18.5 minus 9.81 into 5 plus 17 minus 9.81 into 4. Okay, so now if you find out this effective stress at the past, this effective stress is going to be 247.21 kilopascals. This is at the past. Now, due to present water table, so present stress, same at center of clay layer. At center of clay layer, so you tell me. Now, gamma of a sand into 5 meters, right? Now, water table, so here the water table is at whom? 5 meters, right? Plus gamma dash of a sand into 10 plus gamma dash of clay into 4. Again, you know the unit weights, 17.5 into 5 plus 18.5 minus 9.81 into 10 plus 17 minus 9.81 into 4. So if you solve, this value is going to be 203.16 kilopascals. So I got the present stress, I got the past stress. Now what is over consolidation ratio? Pre-consolidation pressure by present stress. What is meant by pre-consolidation pressure? The maximum pressure at which soil got consolidated. You tell me, out of the past and present, which stress is the maximum? 247.21 is more than 203.16. So now the pre-consolidation pressure is nothing but the maximum pressure out of these two, 247.21. So that over consolidation ratio is equals to 247.21 divided by 203.16. Now, if you solve, you are going to end up the answer as OCR is equals to 1.216. But as it is asking rounded to 2 decimals, so the answer is going to be 1.22. See, if you know the definition of OCR, over consolidation rate, pre-consolidation pressure by present stress. What is pre-consolidation pressure? The maximum pressure at which soil got consolidated. Out of those two, which pressure is maximum? Past is maximum by present, 203.16. So this is how the question goes. We know how to find out this, and now the small litigation it has given is finding the over consolidation ratio. Okay. So there is a 2 marks question, and now coming to this question, the cohesion, angle of interflexion, unit weight, everything is given. The maximum depth of the unsupported excavation, they are asking, what is the maximum depth of unsupported excavation, my dear? Critical height, right? So how to find out the critical height? HSE is equals to 4C by gamma root Ka. So phi value is given as 20 degrees. If phi is 20 degrees, I have given you the handy numbers, Ka value is 0.49. That's it, right? So now you please substitute this. HC is equals to 4 into the C value is going to be 15 by gamma 17.5 into square root 0.49. These type of questions I have given n number of times in the test series also. So after finding this HC is going to be 4.897, but as it is asking rounded to 2 decimals, 4.897. So rounding, after round off, you are going to see it as a 4.90 meters. This is the answer. Okay. Now let's see this question. In a odometer apparatus, a specimen of fully saturated clay has been consolidated under a vertical pressure of 50 kN per meter square and is presently at equilibrium. So the effective, see, listen to the question carefully once again. The test is odometer apparatus, okay, which means consolidation test. Specimen of fully saturated clay has been consolidated. So already soil has been consolidated under a vertical pressure of 50. You know that what is the meaning of consolidation? Expulsion of pore water or dissipation of excess pressure. Yes, if I say the soil got consolidated with some pressure, at the end of the consolidation, the entire pressure I applied 50, at the end of consolidation is going to be effective stress. And what about excess pore water pressure? 0. So it is clearly mentioned, you apply 50 kilopascals on the soil and the soil got consolidated. Now at the end of consolidation, what is effective stress now? 50. What is excess pore water pressure? 0. Okay. And is presently at equilibrium. Equilibrium means so it has been reached the consolidation. The effective stress and pore water pressure immediately on increasing the vertical stress to 150. On increasing the stress means initially how much? 50. And how much you are going to increasing to 150. Then how much pressure you are increasing? 100 kilopascals of pressure you are going to increasing. So the increase in the stress, delta sigma is 150 minus 50, which is going to be 100 kilopascals. Okay. Yes. Now you have to understand one thing clearly. I am asking you the effective stress and pore water pressure immediately on increasing the vertical stress. I am not asking you at the end, I am asking you immediately. See, at the end of the already given, so initially at the end of the first 50 kilopascals, what is effective stress? 50. What is effective stress? 50. And what is excess pore water pressure? 0. And now I have increased from 50 to 150. How much extra pressure I added? 100. Now I am asking you immediately, Are Baba, you are increasing the pressure 100 and immediately the entire excess pressure will develop as 100 kilopascals. And is there any change in the effective stress? No change in the effective stress. So due to 50 kilonewton per meter square initially effective stress, so initially effective stress is 50 kilopascals and excess pore water pressure is going to be how much? 0. Yes. So now due to increase in pressure of 100 kilopascals, due to increase in pressure of 100 kilopascals. So I am asking you immediately what is the increase in the effective stress? 0. You know that immediately entire pressure will be taken by water. So what is the change in pore water pressure? 100 kilopascals. So now what is the total effective stress? You tell me, what is the total effective stress? The total effective stress is initially it is going to be 50. Now immediately after increasing 0. So final effective stress is 50 kilopascals. And what about the pore water pressure? Initially it is going to be 0. Now it is going to be 100. So it is going to be 100 kilopascals. Simple, my dear. up to 50 already consolidation completed. So no excess pressure is there, only effective stress. And how much you increasing from 50 to 150? 100. Immediately that will develop as excess pore water pressure. So what is the pore water pressure now? 100. And no increase in the effective stress. What is effective stress? 50. So the answer would be as effective stress is going to be 50 and pore water pressure is going to be 100. So answer is option D. Answer is option D. So this is about this question. Now come to this question. An unsupported slope of a height of 15 meters is shown in the figure. So this is a slope which is a 15 meters that's shown in the figure, and as it is a finite slope, so the failure arc is going to be slip surface, which is a circular arc having a center O, and this is going to be make an angle of 60 degrees. And if you observe, the radius is going to be, what is the radius over here? So this is nothing but the radius 25 meters, and this slope has an inclination of 50 degrees. And if you observe, this is a failure wedge, my dear. So whatever this is a failure wedge, and it has some weight. So now let's go back again. An unsupported slope in which the slope makes an angle 50 degrees. The slope metal comprised of purely cohesive having undrained cohesion as 75 kilopascals. So what is this value over here? If you observe, it is a purely cohesive, so that cohesion is nothing but 75 kilopascals, my dear. And a trial slip surface with a radius of 25 passes through the crest and toe of the slope. What is the meaning of crest, top and toe of the slope? And the weight of the active soil bounded is nothing but 2500 kN per meter. So KLMN, whatever this KLMN, so this entire failure wedge, this weight is going to be how much? 2500 kilonewton per meter. 2500 kilonewton per meter. Now, which is acting at a horizontal distance of 10 meters from the toe. See, if you observe, this line is exactly vertical now. So now this is a centroidal distance. This is center of gravity, and this centroidal distance is nothing but x. What is this x? 10 meters. It is already mentioned. If this is the case, consider the water table to be present at very large depth, so no effect of water table. You don't need to worry about whether it is a canal full condition or canal drop down condition. Considering the trial slip surface KLM, what is the factor of safety against this failure under undrained condition? What is meant by undrained? Total stress analysis. Arey Baba, this is simply factor of safety. You know the factor of safety. Yes, and mind it, this is a purely cohesive soil, which means phi u is equals to 0 degrees. Have you remembered the finite slope phi u is equals to 0 degrees analysis? If you remember, so factor of safety is nothing but Cu into L bar into R by W into X. What you need to find out here? You know Cu, you know R, you know W, you know X. You need to find out L bar, length of this arc. What is this arc? KLM. So what is the length of arc? R theta. R 25, theta 60. So the question is bigger, but the methodology you know directly. So what is the length of arc? R theta. So what is the R value? 25 into theta 60 into in radians pi by 180. So if you solve, you are going to end up the L bar as 26.18 meters. So 26.18 meters. And now after solving this, then you find out the factor of safety. So what is Cu? 75 into 26.18 into R 25 by W 2500 into 10. So if you solve this one, you will be ending the factor of safety as 1.9635, my dear. What is the factor of safety? 1.9635. But so as it is a NAT, numerical answer type, and it is a round off to 2 decimals. So if I do round it off, it is going to be 1.96 only. So again, this is a 2 marks question. So far and so good. So if you go back and if you check how many marks that has been obtained. So There is a 1 mark question. This is 2 marks question, so 3 marks. There is a 2 marks question, 5 marks. There is also 2 marks question, 7 marks. There is 1 mark question, 8 marks. There is a 2 marks question, 10 marks. And this is a 2 marks question, 12 marks. And there is a 1 more question, so that is based upon the hydraulical conductivity. That we will see. Now again, this is a 2 marks question, so 14 marks total in the morning session. Now last question. Two reservoirs are connected through a homogeneous and isotropic aquifers. You know the aquifer, water bearing strata. So this is an aquifer if you observe. So this is reservoir 1 and this is reservoir 2, and these two are going to be based upon, so these are going to be, these water levels have a difference, whatever this difference, these head loss. So what is the difference? So from here 30 meters, this is 10 meters, 30 minus 10 which is equals to 20 meters, my dear. So from the reservoir 1 to the reservoir 2, the water is flowing through the aquifer. So these two reservoirs are connected, and the hydraulic conductivity, what is meant by hydraulic conductivity? K value, right? Permeability, coefficient of permeability is given as 25 meter per day, and effective porosity is given as 0.3, porosity is given. Now it is shown in the figure. So after showing, the groundwater is flowing in the aquifer at a steady state. You know that this is higher water table, this is lower water table, and the water will flow into this aquifer at a steady rate. If the water in reservoir is contaminated, then the time taken by the contaminated water to reach the river 2 will be, if you observe, so if the contaminated water travels from here to here, what is the distance it is going to be travel? It is going to be exactly travel this 2 kilometers only, because this is an inclined seapace. And how much time? Whenever I said you the time required to reach, that depends upon the actual velocity known as a seapace velocity. So what is the distance here? 2 kilometers. If you know the seapace velocity, distance by time, then I can find out the time. Okay, but we know from the Darcy we have only seapace velocity or discharge velocity, discharge velocity. But once we know discharge velocity, we can find out the seapace velocity. Okay, so now let's see. You know that V is equals to Ki, but where V is not actual velocity, V is a superficial velocity. So what is the K I have given? 25 meter per day into I means H by L, right? What is H over here? 20 meters. I means H by L. So 20 meters, and what is the length that the contaminated water is going to be traveled? 2 kilometers, na? Which means 2 into 10 to the power of 3. So if you solve, this is going to be 0.25 meter per day. But this is what? Seapace velocity? No, this is a discharge velocity. But I want time. So the time depends upon the actual velocity. So actual velocity Vs is equals to V by N. And this Vs is nothing but length by time, right? Is equals to V by N. So I want the time. Now from here, so what is the length? 2 into 10 to the power of 3, 2 kilometers by time is equals to, what is V? 0.25 by divided by N value. What is N value? 0.3. 0.3. So if you solve, this T value is equals to 2400 days. 2400 days. So as simple as that. See, this is the same type of model which has been appeared in 2018 GATE also. So that's all about the geotechnical engineering in the morning session. So which comprises of 14 marks. There is nothing new except in the retaining wall. What happens in the, if the water gets filled in the cracks. Okay. So that's all with the morning session, and we'll see the afternoon session also later.